have the honor to introducing Eleni Santirinaiou, who's also a friend of mine, I should say, and also a data and AI specialist at Microsoft. Eleni is a Microsoft data and AI specialist, part of a MEA Global Black team. You will find her helping customers leverage cloud for the data estate, doing deep dive workshops to build their data architecture and explaining the database internals. But today, Eleni is going to talk about database design for software as a service multi-tenant applications. So welcome, Eleni, and thanks for being here.
Thank you so much. No problem. So welcome. Today, in these 14 minutes, we're going to discuss about database design for software as a service applications. My name is Eleni Santirinaiou, and I'm a global black belt specialist at Microsoft, helping in my job customers in Europe, Middle East, and Africa to take advantage of Azure databases. Outside of my job, I'm very excited that the ski season starts now in December. So come talk to me about the slopes that you will probably slide, how much you lift, and if you are a coffee addict, then consider yourself a friend of mine. Okay.
Good. All right. By the end of the session, I expect that you would have a deeper understanding of the approaches and the trade-offs that we need to make when designing databases. And we're going to discuss about databases both in the relational world, so SQL, but also NoSQL. And this when we design multi-tenant solutions. Why is this important? According to Gartner, the worldwide spend for public cloud in 2023 will be $590 billion. And actually, 1/3 of this will be towards software as a service solutions. And although we expect that the SaaS paradigm will be the most impacted from the inflation, we still see a continued growth forecast of 16.8%. Also, the companies that run purely on SaaS keeps increasing, and in 2023, we will have 86% of the companies running purely on SaaS, which means that the companies that run on license models will decrease, right? Now, the vendors that build software as a service solution usually follow a multi-tenant approach, which means that multiple users share resources. And to do this, they will share compute, network, and storage. The partitioning, the sharing of storage is actually one of the most complicated and challenging problems. And the reason for that is that although there are some practices, some approaches that are universal across the services, specific technologies have specific strategies. So when you move to cloud and you will have, for example, on Azure, dozens of databases, you still have to remember that each one of those will have its own strategy. Some fundamental ideas that we need to clarify so that we are all on the same picture is basically what is a tenant. A tenant is a term originated from the real estate paradigm, right? So we have a tenant renting a house, but in IT is a person, a user that rents resources. So nothing belongs to us anymore, we rent. And in some examples, an accounting system vendor, for example, that builds a system to provide services about payroll, expense management, and so on, will have a customer that is an entire organization. And this organization will store the data in the accounting system, in our accounting system. At the same time, another organization will do the same. So in a B2B example, the tenant is the organization. On a B2C system, where we have, for example, a music streaming service, each individual will store their data in the service, and although all of them use the same service, we expect that each one of them will have a different set of data. Like they will have their playlist, the likes, their play history, and so on. Apart from the individuals here, we might add some family tiers where a group of individuals will share the same billing account and even some data. So in a B2C paradigm, the tenant is actually the individual or a group of individuals. It's a bit tricky to define the tenant, but all the tenants share some characteristics. And these are that with the vendor, they have a commercial relationship, so they are their customers. There might be one user, like in the music streaming example, but also many users, as the example of the accounting system. And they expect some security boundaries for the data. And also, they expect the same experience no matter when they use the service or who else uses the service. Who builds typically solution as a service services, a product, is basically the independent software vendors. Think of the likes of Oracle, so the big houses. Also some startups. Think about Zoom, that they have also the individual B2C model, but they have also the B2B model. And think about also enterprises that they might build a platform to share resources, to share applications with internal line of business. Speaking of multi-tenancy, we speak about sharing resources. This can be from the application binaries, so the code, to the data itself and also the infrastructure. And you, as a vendor, will come and decide how you will optimize your efficiency, how you will optimize your cost, so in what level and with what manner you will share your resources. But at the same time, the customer comes, the tenant comes, and have specific requirements. And these are usually in two axes. One is the data isolation. So I expect that my data will not be shared across other tenants, and the performance. So I expect that the other tenants will not impact the performance I experience in the application. Good. Now, the design considerations fall into 4 categories. These are scale, isolation, complexity, and cost. Scale is the most obvious one. It's a different architecture if you build for 5 tenants. It's a different application if you build for hundreds of thousands of tenants. The other thing is the storage. Storage per tenant means basically that you don't plan only for your average tenant, you plan also for the whales, so the huge ones. I was speaking with a customer that they are building in a bank a trade system where the majority of their users are like you and me, so they're doing a couple of trades per month, and they have those whales that they're doing hundreds of thousands per day. So the same solution should serve all tenants the same way. And then it's the total storage and the type of the workload. So the type of the workload refers to how much reads we have versus writes, or how seasonal is our application. In the music streaming example, we expect that the traffic will be the same across the entire month, right? People listen to music. But on the accounting system, the traffic is different. In the end of the month, we expect a big peak where all the payrolls, the salaries are done, and in the rest of the 90% of the month, we expect some idle behavior. And what this changes is basically the choice of our data store. We need an elastic and scalable store. Then we have the isolation, which is also what contractually or regulatory we are obliged to provide. The customer might require to store the data in the local geography and not outside of this. And also in the performance isolation means that if I borrow from the real estate paradigm, we want to avoid the noisy neighbors. We want to share consistent experience no matter how many tenants run on the same time. Complexity is many times overlooked, but it really shows the effort that will be required to operate and manage the solution. We have, as we design, we have to consider this. How much customization will allow to my users? Will allow separate schemas for each one of them? How I'm going to restore if a tenant will drop their table, will drop their data? How I'm going to monitor, how I'm going to do the billing. So these are the questions that also will affect the design. And lastly, we have the cost per tenant. The cost both in the overall cost of the solution to run the application, but also the cost per tenant. So if I have the music streaming paradigm and I offer quite free service, a freemium service, then I want to minimize the cost. Where if I have a subscription model that has different tiers, like the gold, bronze, silver, then I'm okay and less sensitive on the cost per tenant. How all this translates into approaches. And we're going to talk first about the SQL, because the SQL is also the mother of the databases, and since it has been so long in the IT world, it has also the most databases too. It's not a binary decision. It's actually a spectrum, and basically we will move in this spectrum in the next slides. We start from the follow, share nothing, and go to share everything on the other side of the spectrum. The first thing we can do is basically to have a single database per tenant. Here, in our application, each tenant, each tenant runs in their own database. This allows us high scalability because basically you can independently scale each tenant of yours to a scale up, again with the limit of the database itself, because each database will come with their own limits. And it's very good, for strong isolation. So if you have contractual obligations to stay isolated from other tenants, then this is the best approach. The cost there will be medium because you need to provision separate databases for your tenants, and the customization is quite simple because it's in separate instances. As the number of tenants grows to a large number, we may need a catalog database, which will store the metadata of the databases so that the application will look up and see where the data resides. Next, we go to the other extreme of the spectrum, share everything. So now all our 4 tenants are running in the same database. Here, we are more prone to noisy neighbors. The cost is lower. This means that we have high tenant density, and the customization can be challenging. Like imagine to try to restore a tenant here. Imagine that you might have different indexing. So all this becomes more difficult when you share the same database. And lastly, we have a combination of the two. So in the combination, here we are running 10 tenants across 4 databases. And we call these databases shards because it's for the same application but for different tenants. And we see that, for example, in the first database, we have 3 tenants, but tenant G, that it might be a bigger one, will be stored in one single database. This allows us almost limitless scalability. And the reason for that is that the more tenants will arrive, we keep adding shards. Good. And then how you manage those tenants? Because this will add complexity to the application. Right? Now the application needs to know exactly where the data resides. either by hashing, so the database will know where to talk to, or by a catalog. So in the relational space, you don't see this very often. There are databases like Postgres, and if you want to look up Postgres Citus exception, that basically transforms the single node relational database that we knew to a scale-out distributed database. And this is achieved by having a primary node that will do all the hashing and route the traffic to the right node. NoSQL. First of all, why we see NoSQL databases? Two reasons. One is that the developers that deploy and develop for cloud-native applications, they love the schema flexibility. We don't need to enforce any schema on the database. What we store in the document databases like MongoDB and CosmosDB are JSON documents that don't enforce any schema. And basically, this allows you to be more flexible when you do the queries or when you store the data with completely different schemas and columns. The second reason is the scale out. We said earlier that in the relational databases, we have a capacity. Like the moment that you reach the, I don't know, the 32 CPU cores or the storage, this is it. You need to add the shards that we said earlier. In the NoSQL databases, this is handled by the DB, which means that the more data you add, the more throughput you need, the database logic will know how to scale this out, how to distribute the data and partition the data, and basically offer a virtually unlimited storage. So these are the two reasons. Let's see now how this translates in the resource model. And although here you see, I hope you recognize the CosmosDB logo, this applies also for Mongo, for DynamoDB, and other cloud-native databases. At the root of the hierarchy here, we have the account. In the account level, you can configure certain knobs, we call them, so you can have the geo-replication, so decide where to deploy. You can have customer-managed keys, backup policies, and so on. Under the database, under the account, we have the databases. And the databases are mostly a logical grouping of the next level, the containers. Think about the containers, and I know that the term is not the one that you expect now to be. The containers, think them as tables in the relational with the difference that there is no, you can store different entities. The containers, you will see them in the literature to be called also collections or graphs or any other NoSQL data model paradigm. It's where the magic happens. Basically, at the container level, you can provision the throughput that you expect for your database and for your workload, and at the same level, choose the partition strategy. So it offers a scale-out storage and unlimited scaled-out storage. And under the container is where we store the actual records of the database, which are the JSON documents. Good. Let's see how the models that we saw, the approaches that we saw earlier for the relational, will apply now to the NoSQL. First of all, we have the way of a database account per tenant. Here, we have strong data and performance isolation. Different locations can be configured, the customer-managed keys that we mentioned, the backups, and so on. The cost per tenant will be a bit higher because, as we said, you have to deploy the resources. And the customization is really simple because whatever the tenant does can be delivered. Although this might seem to you like a management overhead, there are customers, and especially I have one in mind, which is the biggest ISV in Europe, that they choose to deploy their entire application stack with all the services, with all the databases in completely different subscriptions in order for them to manage the billing easier. You can apply policies, you can apply billing in the different subscriptions of the cloud. Next one, container per tenant. So here, we have strong performance isolation. We said when we saw the hierarchy of the resources that you can provision throughput at the container level. So we have the performance isolation. We are not prone to noisy neighbors. The cost per tenant doesn't change much for when we deploy on the account level. So it's the same if you deploy here. It's the same if you deploy here. And it offers some medium customization, so you can still tweak the indexing, but you cannot tweak the replication, for example. You have to go with the default one that is configured at the account level. Very good approach if your tenants consist of one container. What happens if a tenant consists of multiple containers? So I'll give you the example of a partner that I'm working with who they built content management. By content management, we mean that each of their tenants is actually a website, a portal that has a number of products, product details, product details in different languages. So for these tenants, they need 30 to 50 different containers. This would be such a mess if it was running under the same database. Oh, I will learn it. If they were running at the same database. So what they have done instead is that for each tenant, they provision a logical grouping, a database for each tenant, and under the database, they share the resources across the multiple containers of the tenant. Okay. And last one, shared containers for everyone. So here, all our tenants' data are stored in the same container, the same table that we said, the equivalent. We have much lower isolation. So imagine if you have a tenant out of these four that demands resources all the time, the others will not be very happy. But at the same time, the cost per tenant drops dramatically. It starts from 0. The customization can be really challenging. So you cannot scale them individually. You cannot restore them. But since you have to manage only one container, your life as an operator is much easier. Who would use this example, you think? The music streaming service, that the data that their users, the tenants store will be low, will be very few, would be okay with that. Like all of their users will share same patterns, so same number of likes, same number of playlists and so on. So this would be fine. Also, I was discussing with a colleague the other day about the customer that they have to serve 2 million tenants, and they had to move from their current infrastructure to an infrastructure to minimize the cost. And the cost per tenant they were aiming for was 5 cents per month per tenant, which, as you can imagine, it's not very easily met when you deploy entire databases. They will have to sacrifice somehow the isolation in order to bring the cost down. How Microsoft does it. So Microsoft is one of the big software houses. They have multiple software as a service applications, from Xbox to Teams and Office. But we will see today the Dynamics 365, which is a set of software as a service business applications that have from marketing services, sales services, customer management services, all this, and help other companies to run their entire business. When Microsoft decided to run this online, they said, okay, we're going to do it our way. We're going to put it on data centers. We're going to manage the servers. That will be fine. And it was fine until the number of active users grew to millions. This is where the principal engineer came to admit that it is painful for both our customers and both our engineers to manage this level, this size of a solution in a traditional infrastructure. And they decided to go to Azure. It took them like two years to move this entire monolith to Azure. But basically what they did is that they adopted the Power Platform. The Power Platform is on Azure, a low-code, no-code platform that is built on the infrastructure of Azure, but somehow abstracts it. So it uses the compute, the storage, and the network of Azure, and also Azure SQL. So the Dynamics team knew that they have to use Azure SQL. The second decision they had to make about their data is to not just use Azure SQL, but use Elastic Pools. Elastic Pools is basically a way of pooling resources and sharing those resources across multiple databases. Why would you do that? The reason to do that is that, for example, in the accounting system example, we are not using the entire resources that we provision all the time. We use them in very infrequent times. So in that time, the resources are shared for other databases. Now, what was a bit challenging for them was that the number of databases they had to manage. The number was 2 million databases. And Azure SQL Elastic Pools offers some features, so they can move databases from one pool to the other. But doing this for 2 million databases was impossible. And this is when they called the Spartans. The Spartans are basically a resource management layer that is built on top of the Power Platform, and they expected it to do the following: to be flexible in sizing and capacity planning, to scale resources of individual tenants in an agile way, and to optimize price and performance. And how they do that? They did that, no, you will not be able to read, but so we have on top of the thing, on top of the architecture here, the scale group, which is how Power Platform manages the data. Different scale groups. Each scale group has a number of logical servers, and each logical server has different tiers of Elastic Pools, 5 different tiers of Elastic Pool. So based on the SLA that is promised to the customer, we put their database to the right tier. We have the standard, general purpose, premium, business critical, and basic. Now, you see at the diagram on the bottom left that each tenant basically runs their own database. And what the Spartan will do in this situation is that it will measure the CPU utilization of the database, and it will move it to another pool that has available resources and belongs to the same tier. Thus, we optimize the efficiency and the performance of the databases. What it also will do is that if a database will grow to demand more resources that are available in the pool, it will move it to a dedicated SQL database to serve these needs. So we see that what Microsoft decided to do in this situation is to provide each tenant with their own database, so prioritize the isolation of the data, but also optimize for cost to share resources that were in a pool. And moving towards the end, we have the key takeaways. The key takeaway, the most important one, is understand your tenants' requirements. What is that they need? What is the level of isolation? What is the level of SLA that you had promised them? And then the decision to design your database will be a trade-off between the isolation and the cost and performance efficiency that suits you as a vendor. Lastly, as you saw, as you remember the spectrum, it's not going to be an all-in for sharing everything or sharing nothing. It will be a hybrid strategy. And to make this more concrete, what we would need to do in that case would be to t-shirt size our tenants. Those whales will be probably in a premium offering, where they will be offered a database per tenant, and the others that are freemium, that are smaller, that have similar patterns, will share resources on the same collection in the NoSQL or on the same database in Relational. And lastly, we want to isolate the hot tenant. So even if we have the music streaming service and we put everyone together, and we might end up with a tenant that is very busy, then you want to protect the rest and isolate them in a different setup. Thank you. Questions?
Thank you very much, Eleni. So, being the presenter, I have the privilege of asking the first question.
Perfect.
So, when it comes to, we talked about very multi-tenant applications, like you have a B2C application where you have multiple tenants, so you use a single container or a table. And we talked about, partitioning and provisioning new databases for each customer. But what happens if you have like enough number of customers, so you need to automatically provision this infrastructure? How easy it is, and what would you recommend as a way of provisioning new customers? So you don't want like a 2 or 3 days onboarding, you want to be done like in a few minutes or hours?
This, I will say that it's more on the application and the pipelines of provisioning, right? On the database side, what we would expect is to simplify it as much as possible, right? This will look, in many cases, as sharing the same collection. So you just enter, basically, a new tenant by writing a new record, right? So depending, again, on what is the needs and the requirements of these tenants, it will be most probably sharing as much as you can.
Okay, so sharing. Do we have more questions, or should I get going? Oh, nice. Okay, I'll stop and let the audience ask things. So what does OPA mean? I can answer that, but it's not very technical. It's a Greek word, and it means like, let's have some fun. Is this a
yes,
thing?
or oh shit.
Oh shit, yeah, it could be that as well. So how do we ensure high availability, and what data recovery capability options are there?
Well, this is the good about running on cloud, right? Most of the managed services on cloud offer this out of the box. So for high availability, the Azure SQL, the Cosmos DB, and with multiple replicas at the same time, either at the storage or at the storage and the compute. So this is managed by the service. The DR capability is either deploying in multiple availability zones when you deploy on cloud, or basically being able to restore from a backup, right? So this is again managed by the service, the platform as a service, or the database as a service.
Okay, so excellent talk. Thank you, Eleni. So when you use the shard model, do you also isolate the resources like an ex-CPU? For example, CPU, it's a database we'll use in order to avoid delays from a database that might have intense traffic. Do you follow a specific design pattern for this situation? Any tip for that?
Yes, very, very good question. Yes, you can limit the resources that are used by each database. Now, I will tell you specifically for Cosmos DB, which is my favorite child, is that even in the SDK, this is something that you can manage at the SDK. So say how much of the provision throughput can each collection or each service, microservice, can consume. But also, when you deploy the elastic pools that I mentioned in the Azure SQL, you can set a minimum and a maximum of the resources that can be consumed by each database in the elastic pool.
Thank you very much. So thanks a lot, Eleni, for being with us today.
Thank you.
This is for you.
Oh, thank you.